we are now on question number 6. We are given that the magnitude of vector PQ is 20 units, given that OP is equal to 5 on 0, and OQ it is 17 on Y. Find the positive value of Y. So, all what I understand is, first of all, solution. How do we answer this question? Say never, never. We are about to answer this question in this way. What I know is the magnitude of vector PQ is 20. I have to change vector OP to this is a vector, it's a column vector, 5 only, that one. So I have to change it into a coordinate. So 5, 0, that is my coordinate. So I have to change vector OQ, which is 17 on Y, to a point which is Q, 17, Y. So now I have to name these points as X1, Y1, X2, Y2. Fellow viewers, I hope you have understood. So are you able to change a column vector into a coordinate? If you are able to do that, that is very beautiful. When you reach that stage, I know that the distance between 2 points, that is on the Cartesian graph, the distance on the Cartesian graph, meaning that on X or Y plane, how do we find the distance, which is the same as magnitude? We are saying distance, in this case magnitude, distance is equal to the coordinate for x2 minus x1, you square it, plus the coordinate, the difference between, for delta y, in short, the difference in y, then you square it. This is the formula of how to find the distance. Distance is as good as the magnitude. So we are going to look at that. So far they have told me that in this case, my magnitude, which is distance, is 20. So I have to substitute this. I'll say 20 is equal to the square root. I have to be very careful. What is my x2 is 17 minus 5. Where is my 5? It is my x1. Ladies and gentlemen, there is no need of you panicking. Plus, what is my y2? My y2 is just y minus 0. What is my y1? My y1, it is 0. So it will be 0 there. I have to square this. You agree with me that when you reach this far, you can now tell yourself that, okay, if that is the case, you have to say I've got a 20 and I've got the square root of 144, because the difference between 17 minus this, you agree with me that here you are going to have a 20. Okay, let me just take it here so that I move you with you slowly. I don't want to be here. The difference is 12. Then this 12 should be squared. There the difference is just y squared. When you are there, ladies and gentlemen, I'm avoiding the root. So I have to put the power 2, even here power 2y, so that this and that will go. I'll have a 400. 20 times 20, it is a 400. Here I'll have 144 plus y squared. So from there, ladies and gentlemen, you avoid the negatives. You say 400 minus 144 equals to y squared. So when you reach there, you subtract now. You say, don't make a mistake. If you subtract nicely, I don't want you to make a mistake. You agree with me, this is 6. 5 from there, it is 5. And of course 2, it will be like this. So I'm going to have a situation like 256, which is equal to y squared. Now it's the same as y squared is equal to 256. So here, you have to put the y to the power 2 in front so that you have this. and then you'll find, I want to remove power 2 here. This power 2 or the square, I should introduce the root. But remember, they have emphasized that I'm interested in the positive. So, of course, I was expecting to have 2 answers because of the power 2, but they have told me that, so when you have to find the square root of 256, the answer is 16. I know, so it means I've found the value of O, the positive value of Y. So that's how this question should go about. Now, some things to remember. Are you able to change this vector, a column vector, in 2 points? If you are able to find the vector in 2 points, from there, are you able to employ the method of how to find the distance, meaning magnitude, to that? Once you have that, then therefore you are very safe. So you can see that we just have to employ or use the formula of finding the distance of 2 points for me to find the value of Y. So ladies and gentlemen, I hope you have enjoyed. This is about column vectors, and it is very interesting, this question. Thank you. However, if I wanted, I would have used the vector method. I think in the next lesson we'll see how we can use vector method so that we see how we can answer this one. So that's the thing. So thank you so much.